Welcome to the Quantum Dreams. Tonight, we explore the universe, the mind, and the questions science still cannot fully explain. You do not need to focus. You do not need to analyze. You only need to listen. Your breath slows. Your thoughts ease. The room becomes calm. And we begin with the question of life in the universe. Space contains billions of galaxies. Each galaxy contains billions of stars. Many stars have planets. Some planets sit in a habitable zone. They may hold water. They may hold stable temperatures. They may support life. Scientists use telescopes to study these worlds. They examine starlight. They look for oxygen, methane, and water vapor. These chemicals could mean life, but so far no certain signals exist. The universe remains silent. This silence is not threatening. It is simply quiet. Distances are enormous. Signals fade. Civilizations may be rare, or they may be common but unreachable. Some scientists think simple life is widespread. Complex life may be rare. Intelligence may be extremely rare. Others think life may be everywhere, but hidden under ice or deep oceans. No one knows. And this uncertainty is part of the journey. Now we widen the view. Space itself is not what it appears. The observable universe is only a small region. Beyond the cosmic horizon, we cannot see anything. Light has not had enough time to reach us. This means most of the universe is invisible to us. Some theories say space extends forever. Others say space curves back on itself. Others say many universes exist. Each universe may have different laws. This idea is called the multiverse. It appears in inflation theory. It appears in string theory. It may explain why our universe allows life, but the idea cannot be tested. It remains unconfirmed. Still, it helps scientists explore possibilities. Now, we move to the forces of nature. 4 fundamental forces shape everything. Gravity holds planets and stars together. Electromagnetism creates chemistry and light. The strong force binds atomic nuclei. The weak force powers nuclear reactions. These forces are precise. They work with perfect consistency, but no one knows why their values are what they are. Small changes could destroy atoms. Small changes could prevent stars. The universe seems fine-tuned. Some think this is coincidence. Some think deeper rules set these values. Some think many universes exist, and we live in one that supports life. This question remains open, and you drift deeper into the subject. And now we move into space-time. Einstein showed that gravity is not a force in the usual sense. It is the curvature of space-time. Planets follow curved paths. Light bends around massive objects. Time slows near gravity. This has been tested. GPS satellites need corrections. Without relativity, they would drift. But relativity does not describe small scales. At tiny distances, quantum physics takes over. Particles jump between states. They tunnel through barriers. They exist in multiple positions. Until measured, this is superposition. It is real. It has been observed. But no one knows why measurement collapses possibilities into one outcome. The measurement problem remains open. Quantum entanglement is even stranger. 2 particles become linked. Change in one affects the other instantly. This has been tested many times. It works across long distances. It does not break relativity. No signal travels faster than light. But the connection is instant. No complete explanation exists. These quantum features do not fit with relativity. This conflict prevents a full theory of physics. Scientists search for quantum gravity. They search for a theory that unifies the large and the small. Some think space-time is made of discrete units. Others think geometry emerges from quantum information. Others think reality is built from the tiny vibrating strings. None are proven. The search continues. Now we go smaller. The Planck length is the smallest meaningful distance. At this scale, space-time may not be smooth. It may be granular. It may behave like foam. Quantum fluctuations may dominate. Time may not be continuous. But no experiment can reach this scale. It is far beyond current technology. Still, it shapes theoretical physics. It may hide the connection between quantum mechanics and gravity. Now we shift to black holes. A black hole forms when mass collapses, gravity becomes extreme. Nothing escapes, not even light. The event horizon marks the boundary. Inside known physics breaks down. Hawking discovered that black holes emit radiation. This means they lose mass. They evaporate slowly. But this creates the information paradox. If matter falls into a black hole, information seems lost. But quantum mechanics says information cannot be destroyed. Many solutions exist, none confirmed. Black holes remain one of the biggest unsolved puzzles. Now we pull back to the universe as a whole. Space expands. Distant galaxies move away. The expansion accelerates. Dark energy drives this. It makes up most of the universe, but its nature is unknown. It may be a property of space. It may be a field. It may be something entirely new. Dark matter shapes galaxies. But no one knows what it is. Many particles are proposed, none detected. These two unknowns dominate the universe, and they remain unexplained. Now your mind shifts toward the origin of the universe. The Big Bang describes the expansion. It explains radiation. It explains galaxy distribution. But it does not explain the moment before expansion. It does not explain why the universe exists. It does not explain why physical laws are stable. Inflation theory attempts to fill gaps. It explains uniformity. It explains structure. It may create multiple universes, but it is not confirmed. The deepest origin remains unknown. And that mystery grows quiet around you as we continue. Now we move from the universe into the mind, because the brain is one of the most complex objects we know. Billions of neurons communicate through electrical and chemical signals. Patterns form, patterns shift, thoughts appear, thoughts fade. But the brain's activity does not explain consciousness. You can measure neurons, you can map regions, you can record signals. But none of this reveals why experience exists. None of this explains why you feel aware. This is the hard problem of consciousness. It remains unsolved. Some theories say consciousness emerges when the brain integrates information. Others say it results from complex feedback loops. Some even propose that consciousness is a fundamental property of the universe like space or time. None of these ideas have proof. Consciousness remains a mystery. Now we move into dreams. Dreams occur mostly during REM sleep. In this stage, the brain becomes active. The cortex fires. The eyes move rapidly. The body becomes immobile. The brain creates images. It creates stories. It creates emotions. Dreams can be vivid. They can be confusing. They can be frightening. They can be comforting. Scientists debate their purpose. Some think dreams consolidate memories. Some think dreams regulate emotions. Some think dreams allow the brain to simulate scenarios. Others think dreams have no purpose at all. There is no final answer. Dreams remain partly understood. Now we study time perception. Time in the external world flows at a constant rate, but the brain does not experience it this way. During fear, time feels slow because the brain collects more details. During joy, time feels fast because fewer details are processed. Novel events stretch time. Routine compresses it. This explains why childhood feels long and adulthood feels fast. The brain may estimate time by counting events. More events make time appear longer. Fewer events make it shorter. This theory fits many observations, but the exact mechanism is unknown. Time perception remains a mystery. Now we investigate memory. Memory is not stored in a single place. It relies on networks across the brain. The hippocampus helps form new memories. The cortex stores long-term memories. When you recall a memory, the brain reconstructs it. This reconstruction can change details. Memories shift. Memories fade. Memories blend. False memories appear. Neuroscience understands parts of memory, but the full process is unclear. We do not know how a moment becomes stable. We do not know why some memories last a lifetime and others vanish quickly. Memory is not a recording. It is a reconstruction. Now we move into attention. Attention directs the mind. It selects information. It filters distractions. It focuses on specific tasks. But attention is limited. It cannot process everything. It shifts, it drifts, it resets. The brain uses networks to maintain attention, but the exact reasons why focus fluctuates remain partly unknown. Attention interacts with emotion. It interacts with memory. It shapes perception, but it is not fully explained. Now we connect these systems. Consciousness, dreams, time, memory, attention, emotion. They work together. They shape your experience, but each contains gaps. Science understands many parts, but the full picture remains incomplete. These mysteries form the core of the human mind, and now you drift deeper into them. Now we move into emotion because emotions shape decisions and behavior long before logic appears. The amygdala responds to threats. The prefrontal cortex regulates impulses. The insula monitors internal states. Hormones amplify reactions, but the full system is not understood. Emotions appear quickly. Some reactions occur before conscious awareness. The body changes. The heart rate increases. Muscles tense. The brain interprets these signals. Sometimes the brain misinterprets them. Fear can appear without danger. Calm can appear without safety. Emotion is not simple. It is a combination of brain patterns, body states, memory, and expectation. Now we shift to the subconscious. Many processes happen automatically. The brain predicts actions. It prepares movements before you decide. Thoughts form before you notice them. The subconscious filters information. It decides what reaches awareness. Most signals never reach consciousness. The brain simplifies reality. It hides complexity. And this hidden system influences choices more than conscious thought. Now we explore perception. Vision feels accurate, but the brain edits what you see. Blind spots exist. The brain fills them. Colors change with context. The brain corrects lighting. The world feels stable, but your eyes move constantly. The brain stitches images together. Your perception is a construction, not a direct recording. Now we examine illusions. Illusions reveal the brain's shortcuts. Lines appear bent. Motion appears where none exists. Patterns appear in randomness. The brain looks for structure. It looks for meaning. It sees faces in objects. It hears voices in noise. These illusions show how the brain guesses, it predicts, and these predictions create experience. Now we move into the nervous system. Signals travel through neurons. They move using electricity and chemicals, but the speed is limited. Reaction time has boundaries. The brain cannot process everything. It filters. It chooses what matters. This creates limitations. You cannot sense all details. You cannot detect all signals. The brain focuses on survival, not accuracy. Now we zoom out to the brain's model of reality. The brain builds a map It uses memory, perception, and prediction. The map feels real, but it is not perfect. It updates constantly. It makes assumptions. It fills gaps. This is why two people experience the same event differently. Each brain builds its own version of reality. These versions overlap, but they are not identical. And now you drift deeper into these ideas as the mind builds worlds inside your awareness. Now we move into language because language shapes thought. Words influence memory. They guide perception. Different languages divide color differently. They describe time differently. They encode space differently. These differences change how the brain categorizes the world. Language is not just communication. It is a cognitive tool. It structures ideas. It filters reality. And it limits what you can express. Now, we shift to the evolution of consciousness. Early organisms reacted to stimuli. They followed chemical gradients. Over time, nervous systems formed. They became more complex. They allowed learning. They allowed memory. They allowed planning. At some point, subjective experience appeared. No one knows when. No one knows how. Consciousness may be gradual. It may be binary. It may be a side effect. It may be a feature. Evolution does not reveal the answer. Now we move into animal intelligence. Many animals show problem solving. Crows use tools. Dolphins recognize themselves. Octopuses solve puzzles. Elephants mourn their dead. Bees learn patterns. Intelligence appears everywhere, but consciousness is harder to confirm. Animals behave intelligently, but we cannot measure their inner experience. Their thoughts remain hidden. Now we study artificial intelligence. Machines learn patterns. They classify images. They translate language. They generate ideas. But their intelligence is different from biological thought. They do not have emotion. They do not have self-awareness. They do not experience the world. They only process data. Future AI may reach higher forms. It may simulate human reasoning. It may predict behavior, but it may still lack subjective experience. The difference between intelligence and consciousness remains important. Now we move into the future of science. New telescopes will study exoplanet atmospheres. They may detect biosignatures. Quantum computers may solve problems beyond classical limits. Brain mapping may reveal new principles. Particle accelerators may discover unknown particles. New technologies may reveal deeper layers of reality. But each discovery creates new questions. Science expands. Questions expand with it. The unknown remains large. This unknown is not a failure, it is the frontier. And now you drift deeper into this frontier as your thoughts slow and the world around you fades into calm. Now we move into the question of free will, because the brain prepares actions before you are aware of deciding. Experiments show neural activity begins milliseconds before. Conscious intention. This suggests decisions may start unconsciously. Consciousness may observe choices, not create them. But other theories argue that consciousness can still influence outcomes. The debate remains open. No one knows if free will exists or if the brain simply generates the feeling of choice. Now we shift to the concept of the self. The sense of self feels solid. It feels continuous. But neuroscience shows the self is a construction. It is built from memory, attention, and prediction. Damage to certain regions changes identity. Personality can shift. Preferences can shift. The sense of self is flexible. It is not fixed. Now we explore identity. Identity forms through experience. It forms through culture. It forms through memory. But memory is unreliable. Perception changes. Emotion changes. The brain updates identity constantly. This means the self is not a single thing. It is a collection of processes. It is dynamic. Now we move into the boundaries of consciousness. Some scientists think consciousness emerges from complexity. Others think it emerges from integration. Others think it is fundamental. Panpsychism suggests consciousness exists in all matter. Integrated information theory suggests consciousness increases with structure. Global workspace theory suggests consciousness broadcasts information across the brain. None of these ideas are confirmed. The true nature of consciousness remains unknown. Now, we explore the relationship between the mind and the universe. Some models suggest consciousness and physical reality are deeply linked. Quantum theories propose observers influence outcomes. Other models argue the brain constructs reality entirely. They say the world you experience is an internal simulation. Your brain predicts the environment. It updates the model with sensory data. This model feels real, but it is only a representation. Now, we explore levels of reality. Physical reality is one level. Neural reality is another. Perceived reality is another. Each level has rules. Each level has limits. The brain interprets signals. It simplifies complexity. It filters noise. It creates meaning. This meaning becomes your world. Different brains create different worlds. No one experiences reality exactly the same. Now, we connect everything: free will, identity, consciousness, prediction, perception, memory, emotion. They interact constantly. They create your experience. They shape your life. They determine how you see the universe. And now, you drift deeper into these topics as your thoughts slow and the mind opens space for the next set of mysteries. Now we move into the mystery of death and consciousness, because no one knows what happens to subjective experience when the brain shuts down. Brain activity stops. Neurons fall silent. The body loses function. From a scientific perspective, consciousness ends. But near-death experiences complicate the picture. Some people report vivid sensations. Some recall tunnels, lights, and voices. Some recall floating above their bodies. These experiences may come from the brain struggling during oxygen loss. They may be hallucinations. They may be memory distortions. Or they may reveal something we do not yet understand. Science cannot confirm any interpretation. The boundary between life and death remains unclear. Now we explore the limits of the brain. The brain consumes a large portion of the body's energy. It has limited processing power. It cannot handle all sensory input. It compresses data. It filters signals. It guesses missing information. These limits create illusions and mistakes. They also create creativity and abstraction. The brain works within constraints. Now we move into the extended mind theory. This theory proposes that cognition is not limited to the skull tools extend thought. Language extends memory. Technology extends attention. Even the environment influences decision-making. According to this view, the mind is not isolated, it is distributed. It operates through networks of interaction between brain, body, and environment. Now, we shift to the possibility that reality has an algorithmic structure. Some scientists think the universe may operate like a computation. Physical laws may resemble code. Information may be fundamental. Space may process information. Time may track computations. This idea appears in digital physics. It is not proven, it is speculative, but it offers a framework for understanding complexity. Now we consider the simulation hypothesis. This idea suggests the universe could be simulated by a higher intelligence. Simulations could contain conscious beings. Technology and advanced civilizations may allow realistic worlds. We cannot test this idea. We may not detect the difference between base reality and simulation. Some argue that statistical reasoning makes simulations likely. Others dismiss it as philosophical speculation. No evidence exists. Now we explore awareness itself. Awareness narrows during focus. It widens during rest. It shifts during emotion. It fades during sleep. It returns during waking. Awareness is dynamic. It is fragile. It is influenced by brain chemistry. It is influenced by memory. It is influenced by prediction. Science cannot explain why awareness feels unified or continuous. It remains an active mystery. And now you drift deeper into these topics as the mind grows softer and the world becomes quiet. Now we move into the physics of dreaming, because dreaming is not just a psychological event. It is also a neurological and biological process, shaped by patterns of activation and suppression in the brain. During REM sleep, the brain stem sends signals that activate the cortex. These signals are chaotic. They trigger fragments of memory. The cortex tries to make sense of them. It builds scenes. It builds narratives. It builds sensations. This creates the dream world. The prefrontal cortex becomes less active. This reduces logic. It reduces critical thinking. It allows strange events to feel normal. The amygdala becomes more active. This increases emotion. It explains why dreams feel intense. Motor regions activate, but the spinal cord blocks movement. This prevents acting out dreams. This system is fragile. Small changes alter dream content. Now we examine consciousness cycles. Consciousness is not constant. It rises and falls. It fades during sleep. It intensifies during focus. It dims during fatigue. It shifts during meditation. The brain changes rhythm. It uses different frequencies. Slow waves appear during deep sleep. Faster waves appear during alertness. These rhythms create states of awareness, but the full mechanism is unknown. Now we move into sensory integration. The brain combines signals from sight, sound, touch, and balance. It builds a unified experience, but these signals arrive at different speeds. The brain must synchronize them. It guesses timing. It aligns events. Errors create illusions. Delayed audio creates confusion. Conflicting signals cause dizziness. Sensory integration is complex, and no single region controls it. Now we study neural timing. Neurons communicate through spikes. These spikes have patterns. Timing carries information. Small delays change meaning. Synchronization creates coherence. Desynchronization creates noise. Cognitive functions rely on precise timing. Memory encoding requires coordination. Attention requires oscillations. Perception relies on millisecond differences. But the origin of these rhythms is unclear. The brain acts like an orchestra without a conductor. Now we explore the collapse of perceptual reality. The brain predicts what will happen next. It compares prediction with sensory input. When prediction matches, perception feels smooth. When prediction fails, perception breaks. This creates surprises. It creates errors. It creates confusion. The brain constantly updates its model. It edits reality moment by moment. This process is automatic. It is hidden. You do not notice it, but everything you see is filtered through it. Reality is not raw. Reality is processed. Reality is constructed. And the system can fail under stress fatigue or sensory overload. These failures reveal how delicate perception is. And as you drift through these ideas, your mind softens even more and prepares for deeper explorations. Now, we move into the flow of consciousness, because thoughts do not appear in isolation. They form streams. One thought triggers another. Associations connect ideas, emotions shape direction, memories interrupt, predictions guide attention. This flow feels natural, but it is constructed. The brain generates thoughts automatically. Consciousness observes them. It does not always control them. Now we move into inner speech. Many people think using silent language. They narrate actions. They plan conversations. They rehearse decisions. Inner speech helps organize thought. But not everyone experiences it the same way. Some people think in images. Some think in abstract feelings. Some think in patterns. The brain supports multiple forms of thought. Now we explore intuition. Intuition feels instant. It feels like knowing without analysis. The brain recognizes patterns faster than consciousness. It detects cues. It uses experience. It predicts outcomes. These predictions feel like instinct, but they come from hidden processes. Intuition is not magical. It is compressed reasoning. But it can fail. It can misread patterns. It can follow bias. Intuition is powerful, but imperfect. Now we move into decision-making. The brain collects information. It evaluates outcomes. It weighs risks. But many decisions happen before awareness. The subconscious proposes choices. Consciousness approves or rejects them. Neuroscience studies show neural activity predicting choices seconds before the person feels the decision. This challenges the idea of free will, but conscious reflection still shapes long-term decisions. It sets goals, it sets values, it influences habits. Now we examine the conflict between emotion and logic. The amygdala reacts quickly. The prefrontal cortex reacts slowly. Emotion pushes immediate action. Logic considers consequences. Sometimes emotion wins. Sometimes logic wins. Both are necessary. Emotion provides motivation. Logic provides planning. The brain blends both, but imbalance creates problems. Too much emotion leads to impulsive choices. Too much logic leads to inaction. Now we explore metacognition. Metacognition is thinking about thinking. It allows awareness of mistakes. It allows correction. It allows reflection. But metacognition varies between individuals. Some people reflect deeply. Some reflect rarely. Some are unaware of biases. Some correct them. The brain supports metacognition through networks in the frontal cortex. But these networks are not perfect. They fail easily. Fatigue, emotion, and stress reduce self-awareness. Now we shift to the sense of agency. Agency is the feeling that you control your actions. But the brain predicts movement before it happens. It creates the feeling of intention. This feeling can be distorted. In some disorders, people lose agency. They feel controlled. They feel detached. This shows agency is constructed, not fundamental. And now you drift deeper as the next set of mysteries waits ahead. Now we move into the final set of mysteries. Because even with all the knowledge science has gathered, the biggest questions remain open. We begin with the nature of reality. Physics describes particles, fields, and forces. But we do not know why these ingredients exist. We do not know why the laws are stable. We do not know why the constants have their values. Some theories say deeper layers exist. Some say reality is emergent. Some say reality is information. None are proven. Now we explore the possibility that consciousness influences reality. At the quantum level, observation changes outcomes. Measurement collapses states. Some interpret this as the observer affecting reality. Others say it only reflects how information updates. The debate continues. Now we move into cosmology. The universe expands. Galaxies drift apart. Dark energy grows stronger. The ultimate fate is unknown. It may expand forever. It may cool into silence. It may tear itself apart. It may collapse in a distant future. Each scenario depends on unknown forces. Now we explore the origin of matter. After the Big Bang, equal amounts of matter and antimatter should have formed. But the universe contains mostly matter. Antimatter is rare. Something created an imbalance. This asymmetry remains unexplained. Experiments search for clues. The answer is not found yet. Now we study the arrow of time. Time flows forward. Entropy increases. Order becomes disorder. But the laws of physics work both ways. They do not prefer a direction. So why does time move forward? Why do memories form in one direction? Why do causes lead to effects? These questions remain open. Now we explore the mystery of emergence. Complex systems produce new behaviors. Atoms form molecules. Molecules form cells. Cells form organisms. Consciousness emerges from neural networks. None of these behaviors are obvious from the smaller parts. Emergence is powerful, but not fully understood. Now we explore the brain stability. Billions of neurons fire every second. The activity changes constantly, yet consciousness feels continuous. You do not feel the complexity. You only feel a stable self. This stability is surprising. It suggests hidden organizing rules. These rules remain unknown. Now we move into the deepest philosophical questions. Why does anything exist? Why is there something instead of nothing? Why does the universe allow complexity? Why does life appear? Why does consciousness arise? These questions do not have scientific answers. They remain mysteries. They may remain mysteries forever. And now we connect everything. The universe, life, mind, memory, time, space, consciousness, they interlock, they influence each other, they form your existence. You do not need to solve them. You only need to rest with them. Because the unknown is not empty. The unknown is not frightening. The unknown is possibility. The unknown is wonder. And as you drift into sleep, the universe becomes quiet. The mind becomes quiet. And the unanswered questions wait patiently